right. This learning guide here is called Intersections of Lines, which is what we're going to be working with a lot. But really, we could call this systems of equations, because really what we're going to be working with throughout this learning guide is looking at what are called linear systems or systems of equations. Um, so in this first section, first topic here, we're going to talk about what is a solution to a linear system. And by the end of this lesson, we'll understand, hopefully, what is meant when we say this term linear system. We want to be able to recognize what the solution to a linear system is, or what it looks like. And ideally, we'll be able to, if we're given a linear system, we'll be able to figure out how many solutions there are to a linear system by looking at the slopes of the lines that are involved in this linear system. So to start with, let's go back and talk about a linear equation. A linear equation we've been working with for several years now. It's something like this: 4x plus 2 equals 10. And we know how to solve something like this. We use opposite operations, doing the same thing to both sides. 4x equals 8, and then we're going to divide both sides by 4 to get x is equal to 2. And x equals 2 is the solution to this equation. Now, what does it mean that x equals 2 is the solution? Well, it means that it's the value of x that satisfies the equation. And by that we mean if we look at the left side and the right side of our equation here, our left side is 4x plus 2, our right side is 10. There's only one value of x that when we sub it in for x, i.e. if we take x equals 2 and we sub it in here for x, we get 8 plus 2 equals 10. Our left side and our right side are the same. And x equals 2 is the only value of x that is going to do that when we sub it in. Any other value of x will give us a left side that is different from the right side, so it won't satisfy the equation. So a linear equation has only one variable, in this case x, but it could be any other letter, and our solution is the value of x that satisfies the equation, that when we sub it in, makes the left side equal to the right side. A system of equations, or a linear system, consists of two or more linear equations considered at the same time. So here we have a linear system consisting of the equations y equals x plus 2 and y equals 8 minus x. So notice we have two variables, x and y. Now there's a solution to this linear system, and the solution is the value of x and y that satisfies both of these equations. And we can write it as an ordered pair, x comma y. So the solution to this system is x equals 3, y is equal to 5. Okay? Or we can write it as the ordered pair 3, 5, or the point 3, 5. Okay. How did we get the 3 and the 5? Well, that's what we're going to look at in the rest of this learning guide, is different ways of finding that value of x and that value of y. But x equals 3 and y equals 5 is the only pair of x and y values that satisfies both of these equations. So for instance, if we take our first equation here and we look at the left side and the right side, our left side is y, our right side is x plus 2. If we sub in y is equal to 5, we get 5. If we sub in x is equal to 3, we get 5 as well, right? So left side equals right side. We can then do the exact same thing for our second equation. Left side, right side. Our left side is y. Our right side is 8 minus x. Y is equal to 5. 8 minus x is 8 minus 3, which is 5. So 3 and 5, okay, work to satisfy both of these equations. Now, we could pick a value of x and y that'll satisfy one of these equations. Like, there's lots of values of x and y that will work in our first equation here. So I could pick something like, let's use x equals, I don't know, 6, and y is equal to 8. Okay. When I do a left side, right side check for this first equation, okay, my left side is going to be my y value, which is 8. My right side is going to be x plus 2, 6 plus 2, which is 8. 6, 8 satisfies my first equation. But what happens when we try this with our second equation? Left side, right side. That's silly. I didn't set any of those other ones up like that. Let's do this. Left side, right side. Our left side is y, which is 8. And our right side is 8 minus x, which is going to be 8 minus 6, which is 2, which, notice, left side and right side are not the same. So there's a single value of x and y, single combination of x and y, that is going to work in both of these two equations. Okay. Now, one way of finding the value of x and the value of y that represents the solution to the system is by graphing the equations. Okay? And the point where the two lines intersect is the solution to the system. Because this is the point, it's the only point that is on both of our lines. So in this graph here, we've got two lines plotted. We've got y equals negative 2x plus 8. It's negative 2x plus 8 is this line here. And then we've got the line y equals 2x plus 4. Sorry, minus 4. Okay. The solution to the system is the point where these two lines intersect. This point here, 3, 2. Okay. Or x equals 3, y equals 2. Okay. There are a lot of points that will work, like this is the only combination of x and y that is going to work when we sub it into both of these equations. There are other points that will work on one of these equations, like any point here, 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 like any of those points will work when we sub them into y equals negative 2x plus 8, but they won't work when we sub them into the other equation because those are points that are not on that other line. Similarly, points like, I don't know, 4, 4 and 5, 6 will work when we sub them into this equation because they're points on the line, but those points are not on the other line, so they won't work when we sub them into the other equation. So there's just this one point, 3, 2, which is going to work when we put it into both of those equations. Now, in some cases, we can figure out how many solutions there are to a linear system without having to do the graphing. Okay? So there are three possibilities here. If we've got two linear equations with two variables in them, like we've just been looking at, x and y, there are three possibilities for the number of solutions. There can be one solution, and that's what we've seen in the examples we've looked at so far, that one ordered pair that satisfies both equations. It's also possible that there is no solution, and it's also possible that there's an infinite number of solutions. So let's take a look at each of these three possibilities, and you can figure out which sort of possibility your system falls into by looking at the slope and looking at the y-intercept of the two lines. Okay. Let's look at a first example here. Here is a case where we have one solution. Okay, our equations are y equals x plus 4 and y equals negative 2x plus 1. And you can see that there's one solution. Here it is right here. The solution is the point negative 1, 3. Okay. Now, how can we tell that there's only one solution from just looking at these two lines? Well, let's look at what the slope of our lines are. This line has a slope of 1. This line has a slope of negative 2. If our slopes are different, our lines are going to intersect. And in fact, if the slopes are different, they will intersect at one point. One point of intersection. Pretty easy, okay? Just look at the slopes. If they don't have the same slope, one point of intersection. Now, Here's a second example. Y equals 2x plus 3, y equals 2x minus 4. Looking at the graph, you can see that there is no point of intersection. There's no point where these two lines meet. And this makes sense because these two lines are parallel. Okay, so these are going to go on and on forever, never getting any closer. They're never going to intersect. How do we know that these two lines are parallel? Well, let's look at our slopes. Our slope for line 1 is 2. Our slope for line 2 is also 2. This tells us that if the slopes are the same, this tells us the lines are parallel. If our lines are parallel, they're not going to intersect. Okay? But one other thing has to be true for these lines to not intersect. The y-intercepts, let's say, and y-intercepts are different. Okay? Our y-intercept here is 3. Our y-intercept here is -4. Those are definitely different. And so we have one line way up here with a y-intercept of 3 and another line way down here with a y-intercept of -4. We get this spacing in between these two lines. Okay? So if the slopes are the same and the y-intercepts are different, then no solution. Or no point of intersection. Because they're parallel and they're offset from each other. Okay? Now, what happens if the y-intercepts are not different? We get a situation like this. Okay? Here we have two lines. We can see, it's hard to see here. One's red, one's blue, but they're like right on top of each other. These are in fact the same line. They have the same slope and they have the same y-intercept. So they are going to have an infinite number of solutions because basically they are the same line. So if our two lines here have the same slope and the same y-intercept, that tells us infinite number of solutions. Basically, any point that is on one of the lines is a point on the other line as well, because they share all the same points together. And because there's an infinite number of points on a line, we have an infinite number of solutions. So it's not always obvious that they have the same slope and the same y-intercept. Sometimes they give it to you in the standard form, and we would have to rearrange this. So we would have to rewrite this as y equals -x plus 3, bringing the x over to the other side. So our slope here is -1. Our intercept is 3. And then we would have to do the same thing to this equation here, dividing both sides by 2. Y equals -2 over 2x. So y is going to equal, just rearranging this, -1x plus 3. There we go. Slope is -1. -1. Intercept is 3. These are both the same. So same slope, same y-intercept. We have an infinite number of solutions. So in the learning guide, they give us like a little flow chart to figure out how many solutions a line has. Okay, we've got an example here. We've got two equations: 2x plus y equals 6, 2y minus 7 equals -4. Let's start by finding our slopes and our y-intercepts here. So I'm going to rearrange this first equation, just bringing the 2x to the other side. So we've got a slope of -2 and a y-intercept of 6. Let's rearrange our second one here. I'm going to keep the 2y on this side. I'm going to add 7 to both sides, and then I'm going to divide through by the 2. -4 divided by 2 is -2. So our slope here is -2, and our y-intercept is 7 over 2. Okay, let's start at the top of our flowchart here. Are the slopes the same? Yes, they are. They're both -2. So we're going to follow this path. Now, we ask ourselves, are the y-intercepts the same? No, they are not, because we got a b equals 6 and a b equals 7/2. That tells us that these two lines are parallel. If the lines are parallel, we can say that our system has no solution. So you're good now to do any of the practice questions in practice number 1, page A3 of the learning guide.